Good afternoon, ladies and gentlemen. My name is Maurizio Cocchi, and on behalf of ETA Florence and the MIDAS Project, I'm glad to welcome you today to this webinar, Guayule on Marginal Lands, Building Europe's Value Chain for Sustainable Rubber and Bio-Based Products. So this webinar is organized in the framework of MIDAS or Horizon Europe project. I will give an introduction later about the project, but today's topic is explicitly on one of the value chains that we are targeting with our activities in this project, which is the value chain of Guayule. This is a specialty crop for rubber, latex, and other co-products. And we will hear about what we're doing and what our partners are doing in our case studies from 5 presentations from our partners. And after the presentations, we will have a panel with industry experts to discuss how to scale up, what are the needs and the opportunities to scale up and deploy this value chain at scale. So this webinar will be recorded and all the slides will be available on our website just after this webinar. And you will also receive slides and recording by email afterwards. Thank you for being here. In this moment, we have 51 attendees and counting. So I will just now give a first introduction about the project itself, the MIDAS project itself, replacing our project coordinator, Eftimia Alexopoulos from CRES, which could not attend today. And then I will immediately give the floor to our speakers for today. Okay. Good. So in a nutshell about MIDAS. MIDAS is a Horizon Europe project that was launched in 2022 and will run until the end of next year, October next year. And the aim of MIDAS is to combine the recovery of marginal lands with the deployment of industrial crops and value chains for bio-based products to support the European bioeconomy. So marginal lands are an important issue to tackle at European level. We have over 30% of agricultural land that can fall in the category of marginal. This is let's say, the starting point for the project. So the support to the European bioeconomy. So where did we start from MIDAS? We started from the initial point that the transition to a bio-based economy requires a sustainable supply of biomass while ensuring food security and respecting also our environment and biodiversity. So we believe that a series of selected climate resilient industrial crops could be grown on those marginal agricultural land and could provide sustainable biomass for a wide range of bio-based value chains. And on these premises, we are developing and carrying out this project, building on two pillars. One, on the one hand, we are working to optimize a series of crops that I will show you later, both through crop breeding and through the implementation of tailored agronomic practices. And on the other hand, we are working to improve the functional performance and the resource efficiency of specific bio-based value chains, which will be also the scope of today's webinar, in a biorefinery concept. So in this framework, we're carrying out a series of activities in different work packages. An important component of the project is the mapping and characterization of current and future availability of marginal land in Europe, extension of marginal land in Europe, and especially how they can be used for low indirect land use chain biomass production. We also are carrying out case studies and in our demo fields to grow a series of crops in these environments. The biomass that is produced from these case studies is used for the partners that are targeting the downstream processing of the value chain to produce a wide range of end products and intermediate products. And ultimately, we have partners working on the assessment of the whole value chain, the LCA, the full life cycle assessment, and the analysis of the economic sustainability of the value chains, and also helping to develop functional business plans and business models for farmers, so that these value chains can be deployed at scale after the project. All these work packages, all these activities are integrated at the center. One of the important element, as I said, is the mapping of the available marginal land, but also the case studies that we are carrying out in our fields. And we have a web of case studies. We have 13 case studies with 13 different demo fields across Europe in the map here that you can see here in 9 different countries. And we are using 19 different crops. And Guayule is one of these. Guayule is grown in Spain and in France. Here we are testing and demonstrating both the tailored agronomic practices and the innovative selected varieties with innovative cropping systems such as intercropping and agroforestry, to evaluate how these crops can be suitable to be grown in these marginal areas, providing viable products and income also from a farmer's point of view in these very challenging areas. This is not the scope of today's webinar, but if you're willing to learn more about both marginal lands, have a very deep, in-depth explanation of our case studies, and also learn what we are doing for the biodiversity assessment at all these different case studies, I encourage you to watch the recording and the slides of the past webinar that we had in October. Here you can find the link, and it's available on our website. Another important component of the project is that we are working with a series of regional advisory groups. There is one advisory group in each one of our partner countries, and these are composed by agricultural stakeholders and farmers advisors, organizations that can help us to contextualize at local scale what we are testing and demonstrating at European scale. And here you can see a couple of pictures of recent regional advisory group meetings that are very, very important for us to understand the local conditions. And this will be one of the aspects of one of the new upcoming webinars. As I said, from these case studies, we obtain a very wide range of products. All the crops that I showed you before can be broadly classified into lignocellulosic crops that are mainly used for particle boards, MDF boards, nanocarbon, biochar, and ultimately also bioenergy. The oilseed crops, they are mainly used for biolubricants, biostimulants, biodegradable in soil mulching films, and also phytosanitary products. And the specialty crops, where Guayule belongs to, they are used for latex, rubber, and also adhesive coatings. And we will hear specifically today about this value chain. We are a consortium of 24 partners from 13 countries, including research organizations, industries, and SMEs, and the project is coordinated by the Center for Renewable Energy Sources in Greece. This is the end of my introductory presentation. I want to keep the time for the speakers now to go in depth, to deep dive into this topic. And here you can find the links to our website and all our socials. And now I give the floor to our first speaker, Almudena Olivas del Rey from the Istituto Tecnomico Agronomico Provincial de Albacete, and she will explain and will show us what we are doing in our one of the two case studies that we have on Guayule. Almudena, the floor is yours. In the meantime, I will share the slides. Okay.
Not yet in full screen, Maurizio.
How about now?
No, I think you have to abilita modifica and then switch.
You cannot see it?
No.
No.
It is PowerPoint still?
Yes, it is the PowerPoint that we shared. Oh. Sorry.
Mauricio, I can share my screen, no problem.
Let me try once more and then.
Okay.
Can you see it now?
It is PowerPoint, not the full screen. Try switching the screen.
How about now?
Not yet. Ah, okay. Yes, now it's perfect.
Okay, yes.
I hope it's the right version, Almudena, because I opened two. Sorry. Let me know.
Okay. So, good morning, everyone. My name is Almudena Olivas del Rey. I am an agronomist and researcher at ITAP, the Provincial Agronomic Technical Institute of Albacete in Spain. And it is a pleasure to join you today. I am very grateful for the opportunity. And in this presentation, I will share our specific experience at ITAP with industrial cultivation of Guayule, a promising shrub for natural rubber and resin production under arid conditions. I would like to thank the organizer of the workshop for the excellent organization and for this opportunity to connect and exchange knowledge. So let me start by briefly introduce myself. I work within the research and development department of ITAP, where we focus on applied research to promote innovation, sustainability, and competitiveness in agriculture. At ITAP, I am in charge of the coordination of activities related to this crop, and we have over 10 years of experience with Guayule. And today I will be sharing both the role of ITAP within the MIDAS project and our research journey to develop this crop at that industrial level. So, next slide, please. Before diving into the details, I will begin with some background of the Guayule crop, focusing on its agronomic characteristic and historical relevance. And finally, I will share the experience of ITAP in the industrial production of Guayule. As Mauricio said, MIDAS adopt a research-efficient fuel refinery concept to make the most of the biomass obtained from marginal lands. So the project works with different types of industrial crops, including lignocellulosic crops, oilseed crops, and a specific group of specialty crops such as Guayule. So now let's now take a closer look at Guayule, a specialty crop with a great potential for sustainable production in marginal lands. Guayule, Parthenium argentatum, from the Asteraceae family, is a perennial shrub native to the Chihuahuan Desert, which spans northwest Mexico and the southwestern United States. This plant is naturally adapted to extremely dry conditions, poor soils, and high temperatures, making it highly sustainable for Mediterranean-type climates. As a drought-tolerant, not edible crop, Guayule offers a strategic alternative to tropical rubber production, with potential to develop bio-based value chains right here in Europe. So let's take a look at the main morphological traits of the Guayule plant, starting from the root system. The next, please. Okay. Guayule has a deep central root accompanied by an extensive network of lateral roots. This root structure enables the plant to access water from deep soil layers, making it highly resistant to drought. The next is the stems. are silver gray in color and exude resins, which is one of the commercially valuable components of the plant. The leaves are long, narrow, and greenish-gray, helping to minimize water loss by reflecting sunlight and reducing transpiration. And the flowers are very small, yellowish, and grouped into compact flower heads, as typical in the Asteraceae family. The seeds are tiny, dark in color, and offer variable in shape and fertility, a factor that can complicate seed-based propagation. So Guayule presents a set of agronomical characteristics that make it especially attractive for marginal lands. It has a low demand for nutrients and water. It grows well in poor soil, tolerates prolonged droughts, and requires minimal fertilization. It is able to regrow after harvest, producing new biomass from the base, which allow for multiple harvest cycles and improves the return on investment. Guayule is naturally pest resistant thanks to certain compounds that deter herbivorous insects. This reduces the need for phytosanitary treatment and lower maintenance costs. And finally, it is a no-invasive species. It does not displace native flora and is compatible with sustainability commitments in commercial systems. The next, please. Okay. The history of Guayule includes 4 major development phases over the past century. The first effort began in the early 20th century, led by Mexico and the United States. It focuses on the collection and selection of wild stands, and its peak, Guayule accounted for up to 24% of all rubber imported into the U.S. The second phase took place during World War II under the Emergency Rubber Project. This involved the US, Mexico, and Spain and led to the generation of extensive knowledge of Guayule biology, as well as the development of a rich germ plant base that still support today breeding programs. The third effort emerged in the late 1970s, triggered by the oil crisis. This period saw significant improvements in rubber yield, engaged agronomic practices, and the first serious consideration of Guayule co-products. The fourth and current phase is being greatly larger in Europe, with Spain, France, and Italy playing key roles. Recent progress includes higher rubber yields and the valorization of co-products with industrial potential. It's also worth mentioning that Bridgestone Corporation has experimental Guayule plantation and its biorubber research center in Arizona, USA, where it explores its use in sustainable tire manufacturing. The first attempt to cultivate Guayule in Spain dates back to the mid-20th century, especially between 1950 and 1977. It began with an ambitious plan covering 4,000 hectares in 80 towns of southeastern in Spain. To manage this initiative, the SEMSEI was created, the Service for the Exploitation and Improvement of Arid Zones in Southeast Spain. The productive objective was to generate up to 1,500 tons of natural rubber per year. However, the project was ultimately abandoned due to technical difficulties in the rubber extraction process, which prevented the experiments from progressing. Although this early phase did not succeed, it laid the foundation for the new interest and later efforts to reintroduce Guayule in Spain under more advanced conditions. Yes, next one, please. With renewed interest in Guayule, Spain joined the EU-Pearls project between 2008 and 2012, funded under the European Union's 70 Framework Program. The goal was to identify alternative sources of natural rubber in Europe to reduce reliance on imports. Within this framework, an experimental plot was set up in the Murcia region, where Guayule saw with good adaptability to Mediterranean conditions. However, despite promising outcomes, the plot was eventually withdrawn in 2018. The project nevertheless provides valuable agronomic and climatic data, paving the way for the new research effort in Spain, including the work currently led by ETAP. So, since 2017, an experimental Guayule field has been operating in Castilla-La Mancha as part of a public-private partnership involving ETAP, the University of Castilla-La Mancha, and Nokian Tires, among others. This site holds the largest Guayule heron plants collection in Europe, distributed across 7 experimental plots where 33 pure and hybrid accessions are being tested. The crop has shown excellent adaptation to the semi-arid temperate condition of southeastern Spain, confirming its agronomic viability under Mediterranean climates. Thanks to its results, and genetic diversity, this initiative is positioning Spain, especially Castilla-La Mancha, as a European benchmark for Guayule research and development. This is our heron plant, so the next slide, please. The next, please. Mauricio, thank you. The next.
The next one, this one.
Yes, this is okay. This from there we launched the first field trials of Guayule, and we did not do it alone. We built a strong collaboration with the University of Castilla-La Mancha, and very importantly, with local farmers such as Ángel Jesús García Alonso, who has been a key figure in this process, helping us validate the crop under real-world conditions. Our work is supported by a strategic alliance with university, technology centers, industrial companies, and very important local farmers who are key contributors in this process. ETAP has been responsible for the agronomic research of Guayule cultivation in the region of Castilla-La Mancha. But before sharing our experience in detail, I would like to start with a brief introduction to who we are. The Instituto Técnico Agronómico Provincial is a public research and innovation center belonging to the Diputación de Albacete in the region of Castilla-La Mancha. We focus on agronomic experimentation, technology transfer, and technical progress in the agri-food sector. The next slide. At ETAP, we have become pioneers in Europe in applied research of Guayule. In fact, we were the first center in Spain and in Europe to test and maintain the crop with a long-term perspective. We currently manage more than 7 trial fields, focuses on adaptation, productivity, and agronomic practices. So one of our main goals within the MIDAS project is to improve the efficiency of Guayule cultivation of marginal lands using sustainable resource efficient practices. We are tailoring agronomic practices for low inputs and low water conditions in order to increase crop performance and resource efficiency. An innovative sub-irrigation system in base applies in dry Mediterranean regions as a sustainable alternative to conventional irrigation, and we also promote the circular use of bio-based products developed in MIDAS, applying them directly to crop grown of marginal land. These actions help to maximize productivity while minimizing environmental impact, fully aligned with the goals of a sustainable bioeconomy. So the next slide, please. This is one of the field trials developed by ETAP as a part of the MIDAS project. The next. This is the main crop is Guayule, planted at a density of 26,000 plants per hectare using a section 85 from the USDA. The trial also include the next slide, Mauricio, thank you. The trial also include annual crops such as a flower and industrial hemp. The total area is the plot is 3 hectares, and this field is located in an area that meets marginal conditions: low rainfall, organic matter below 2%, sandy soils over 70%, gypsy service content, and loss of biodiversity in the soil. So it provides an ideal scenario for testing resilient, sustainable agricultural systems in real-world marginal conditions. To monitor and evaluate crop performance, we are also using a drone equipped with a multispectral camera, which allow us to assess plant vigor, stress, and spatial variability across the plot with high precision. The next, please. Thank you. The MIDAS Project trials are showing excellent results. More than 2 harvests have already been completed, and the products obtained from Guayule are achieving very promising values, not only in rubber, but also in resins. Traditionally, research focuses only on rubber, but Guayule also produces large amounts of resin with very interesting and versatile compounds, such as guayulins and argentines, which are being studied for different applications. In addition, new uses are being explored for the bagasse, the plant material left after extraction, and even for the leaves, which were once discarded but are now to contain rubber, resin, and other valuable substance. Manuel Carbona will continue talking about Guayule byproducts later in the session. So the next slide. Why do we believe Guayule is a strategic crop for Europe? First, because of its potential to reduce dependence of imported natural rubber. Europe currently relies almost entirely of external sources, mainly for Southeast Asia. Guayule offers the opportunity to produce natural rubber locally, which strengthens supply chains relations and supports European strategic autonomy. Second, it provides added value because Guayule enables the creation of a new bio-based industrial value chain. And third, Guayule promotes sustainability. It can be cultivated in dry, drainage soils with low input requirements, helping to diversity farming system and encourage more sustainable agricultural practices in marginal areas. Beyond its industrial potential, Guayule also offers clear agronomic advantage for farmers, especially in dry or degrading environments. First, it is a perennial crop with a lifespan of up to 10 years, which means that once it is established, there is no need for annual replanting. This reduces labor and field preparation costs significantly over time. Second, the Guayule requires much less water than traditional crops, making it highly sustainable for water-scarce regions. And third, it allows for a reduction in input cost. Once established, the crop demands low level of fertilizer and maintenance, which makes it a cost-effective option for long-term land use in marginal area. To conclude, I would like to briefly highlight the main perspective for the future development of Guayule and similar industrial crops in marginal lands. First, continued research is essential. We need to keep innovating in the development of high-aid value byproducts derived from Guayule, such as bio-based resin, rubber, alternative, and natural agro inputs. Second, agricultural scaling will be key. Involving local farmers and cooperatives is fundamental to expanding the cultivation of these crops in marginal areas and building viable supply chains. Third, we aim for industrialization. Our goal is to position Castilla-La Mancha, Europe, as a reference region in the European bioeconomy, linking primary production with biorefineries and sustainable manufacturing. And finally, this requires a strong political impulse. It is crucial to develop public policies and funding programs that support farmers, researchers, and companies working in this field, especially in rural and climate challenge regions. To wrap up my part, I would like to underline that Guayule not only has potential as a source of natural rubber, but also as a multi-purpose industrial crop with valuable byproducts that deserve to be explored. So thanks so much for your attention.
Thank you, Almudena. And thank you for keeping the time. Thank you for giving this very detailed presentation about the case study in Spain and what you are doing. Let me stop sharing my screen. I think it was, are you still with us? Yes. I think it was really, we all visited your case study last year, and we were impressed by the farmers and the curiosity and the interest of the farmers in the local area. I really hope that you will progress well with this demo. And in the meantime, I would like to invite all the speakers to use the question and answer panel. I see that there are 3 questions now already. Almudena, unfortunately, will have to leave before the end of the webinar, but in case there are any questions for Almudena, we will address them and then we will reply later. For the other speakers, you can use the question and answer panel. Almudena, thank you again for your presentation. And now I would like to invite Luca Cozzolino from CREA, Italy, to elaborate more on this case study, explaining the collaboration they had on the harvesting of Guayule.
Thank you, Maurizio. I will share my screen.
Yes, please do. Just a second, I'm not seeing yet.
Do you see it?
Yes. Yes.
Okay, thank you for the introduction. I'm Luca Cozzolino from CREA, technical collaborator and PhD student in mechanical aspect of industrial crop. And this presentation will focalize on the Guayule mechanization challenges. As previously mentioned by Almudena, why we cultivate this type of crop, new industrial crop? Because there is a global shift towards sustainable materials and bioeconomies to reduce the fossil and the importation of this type of material. There will be EU directive to incentivize this type of use, and there is the necessity to develop a new local and resilient supply chain to improve the situation of the farmer, principally in the marginal area. Why there is the gap in the mechanization for the new industrial crop? There is a strong and directly correlation between the market demand and the technological response. When there is a stable and strong demand for industry, the technological response from the machinery company respond to this demand by developing and specialized equipment that can improve and lead higher efficiency in whole mechanical phase for this industrial crop. This is the barrier to scaling for this new industrial crop like Guayule. This is the focus of our research group that is a double problem, because if there aren't specialized machine, is a problem for principally for the harvesting, but even there is a specialized machinery in the initial phase of the supply chain. In the initial phase of the supply chain, even there is a perfect machine, farmers cannot afford the high capital to cost until the crop is proven profitable. This is why we applied our protocol to test technology and machinery used in a crop already established. For the Guayule, this example is the lavender. Is a woody shrub. It's very similar to Guayule crop, and this allows the adaptation of the existing machinery to harvesting, and this can be valuable for improve the Guayule harvesting. What is the problem with this type of crop? There is two logistical challenges. This type of products has low density with high volume, and the hypothetic rapid deterioration of the potential products. Guayule is really interesting industrial crop because whole part of the plants could be has a potential byproducts. There are two main harvesting methods concerning the Guayule. The first one is a method that is a direct partially processed process, the shredded work system named the shredded material. The second one is a two-step processing that the entire plant is cut, and then in a second phase, another machine partial processed it. The key point, the key advantage of these two systems is, for the first one, the high work productivity and the limited cost, transport cost, but there is a problem with the resin of the Guayule. And for the second group of the methodology, the bilateral plant, there are a good work productivity, but there is a potential complication with the logistical aspect of the transport or the processing of the material. We carry out a preliminary economical results based on a simulation on the literature and our preliminary experiment. For the two two group of the methodologies analyzed, we have the first one that have a partially processed material with higher cost than the second one, but in the second one is lower, but the material need a partial process to improve the quality of the industrial process. Based on the field experience and the research on the topic, the really problem with the Guayule is the high resin content, because can give some problem with several parts of the machinery. To summarize the presentation, at the moment there aren't dedicated machinery for the Guayule harvesting. The option available is work well for the Guayule crop, but the key point is when we have the final use of the whole plant, we can select the process that could be improve whole plant of the Guayule, and we can select the machinery that can compromise the efficiency and the quality of the final product. Thank you.
Thanks to you, Luca. Thank you. So we understand that there's still some work to do for the full mechanization of the harvesting of Guayule, and we count on your expertise to solve this problem. And before I introduce the next speaker, I would like to invite you all to use the question and answer panel. I see that there are still already some questions. Maybe some were already replied to. And also for the speakers, please check the question and answer panel. So maybe you can type your replies to the questions. Thank you, Luca, again. And now I would like to invite our third speaker, Manuel Carmona Delgado from the Universidad de Castilla-La Mancha. to tackle the downstream part of the value chain, so the exploitation of the Guayule co-products and all what we can do with this biomass. So Manuel, the floor is yours.
Thank you very much, Maurizio. Thank you for organizing this webinar and for the invitation to participate.
I think you still have to share your screen.
I'm sharing my screen, isn't it?
No. We tested before it worked. So in the meantime, yes.
Now?
Yes, it's coming now. Yes, can you put it in full mode, full screen? Perfect. You probably need to switch the visualization to invert the desktop, the screen.
Configuración de visualización. And then switch the screen.
Now it's ready now?
No?
Sorry, I don't know what is happening.
It's fine. If you want, you can share again, and you can use it that way. But it should be fine.
I don't know what is happening.
Sorry.
Sorry.
Let's restart. Can you try and share your screen? Meanwhile, maybe I can get your presentation. Let me see. It's
And this
maybe
is
I
because
have it.
we were
Maybe.
making trials before connection.
Yeah. It always happens like this. I can probably share your screen.
I will try last time. Let me 1 second.
I'm sharing now for you. Can you see my slides?
No, Maurizio. Now, yes. Yes, it's okay.
Okay, so
Good.
Manuel, I will scroll.
Thank
the
you.
screen.
Thank you very much, Maurizio. Good afternoon, everybody. Good morning for the people attending from the USA and other locations. Could you put the next one? As Almudena said, this crop is well known as a source of natural rubber, but there is limitation for the feasibility of this crop just using this material. So next one, please, Maurizio. So today I'm going to try to speak just very few about other products from this crop: resins, essential oil, bagasse, and also isolated compound from the resin, with the idea to make profitable this crop. Next one, please. Next one. So regarding next one, please. Regarding Guayule rubber. Regarding rubber, natural rubber, everybody knows that the main source is Hevea brasiliensis, a crop now established almost only in the southeast of Asia. Even there are more than 205,000 plants able to produce polyisoprene. Only two are industrializable alternatives, which is dandelion for cold weathers and Guayule Parthenium argentatum for warm or semi-arid areas. Next one, please. So what we know about rubber produced from Guayule, it's first maybe I have to make a light explanation. When we talk about rubber, the polyisoprene produced from Guayule or any other source could be in two different forms: as solid rubber, I will talk about solid rubber in this presentation, and as liquid latex. My colleague from Watex, Michel Dorjet, later will focus in this possibility. So regarding solid rubber, there is a good knowledge about which is the production of Guayule and its hybrids, depending on the soils and weather conditions. So And besides, there is a nice knowledge about the extraction procedure, different sequential or simultaneous extraction procedure, able to produce polymers with a molecular size between 800 and 1,500 kilodaltons, which are the polymers that provide the mechanical characteristic that natural rubber should have for the industry. Next one, please. So the challenge for this at this moment is how to scale up the process to make it feasible, because the price from the comparing with the rubber coming from South Asia is much higher. Also because to produce in a lower price this material in Europe, the facilities to extract should be huge, and consequently the surface, the cultivation surface of this crop should be as well very big. So that is a first quick point. Second is it's clear that for obtaining solid rubber, hexane is used. So we should try to replace this solvent because in the European Union recently was released the SS by D approach, which means safe and sustainable by design approach, with the idea to produce materials and chemicals with this point of view. So the needs to replace the hexane that at this moment is used in the extraction procedure, it's also another challenging question that remains. So producing in Europe at higher price with a more sustainable way during a solvent means for sure higher price. This premium price for rubber could be only accepted by the industry for some application, not for larger application, but for small application, niche markets, just in case the LC analysis, I mean, how is the process from cultivation to obtention the product and application takes. So, but at this moment, this is missing. And finally, it's necessary to exploit, as Almudena said, other co-product with the idea to make feasible this. Let's go on, please. About the Guayule resin, also Almudena said that during long time have been perceived like or received very few attention, while the accession produced in the 80s and 90s last century has a content of resin that frequently double the content of rubber. Next one, please. So it's necessary to put attention. So in our lab, we have made trials to use this resin, these bioresins, to make biocomposites with nice performance, nice mechanical properties, and nice performance, for example, regarding one of the challenging needs from composite, which is drilling. So next one, please. So we can apply for several sectors, mainly in automotive or light mobility, but the problem again is to scale up the process, okay? Making feasible, you need a large surface of cultivation and huge facilities for destruction in order to be possible to enter on those markets. Thank you. Next one. Regarding essential oils, till 3-4 years ago that our research team started to study, there were just very few information in the literature. So the most relevant was from the 50s, last century, and a couple of papers later talk about this. For us was a surprise. We thought that the reason why the Guayule fields are smell so nice and so strong is because they can consider. Also, there are a couple of accession like CAL1 and CAL2 that seems very familiar to the farmer because they identify as aromatic plant. So we started to study this. Next one, please. And we realized that surprisingly, the yield that can be obtained from this plant always is over 0.3%. And this is maintained for several of the varieties. Curiously, not the most appropriate varieties for producing rubber are the best producer for essential oils. But what we realize as well is we can produce at the lab in a bottom flax with the same yield we can produce later with the help of our mates in MIDAS Project from CMAT, a large semi-industrial scale, less than 1 ton, and we can reproduce in batches for 6 tons or 20 tons, okay? So this is a nice potential application. Next one, please. That produce a profile of essential oils that later we can fractionate. You have here the profile of different essential oils obtaining from the original one, the Guayule essential oil. And you can see even the different colors they have, next one, because we can try to apply different things for different purposes. So we use it like a biopesticide, and it works like as for fighting against food molds or even agricultural fungi. Also, we use it as insect repellent against the pest moth for tomato plants, Tuta absoluta. Next one. But we can use it as well in cosmetic. You can continue, please. Perfumes, aromatherapy. So there are several applications. The technology for distillation, steam distillation needed for the essential oil extraction is well distributed everywhere. So it's a technology well known and available everywhere. So the challenge, next one, please, Mauricio, is introduce a new product into a saturated market of essential oils. Okay, that's the challenge in this case. Next one, please. What about bagasse? Bagasse, next one. We can use it inside our MIDAS project. There are a couple of partners, Himar from Greece and Balbopan from Portugal, that are producing nice boards with different degree of Guayule bagasse substitution, having nice performance, because one of the things that are beneficial or considered positive is the absorption rate of water. So it's important that this board has a low absorption water, and probably because the remaining quantities of rubber and resin non-extracted in the bagasse, we obtain a nice performance during this board. Next one. So we are studying the possibility to use as filling artificial football courts, and that's another potential application. Next one. And what about isolate compounds? So we have rubber, resin, we have essential oils, we have bagasse, but we can isolate nice compounds from resin. This picture you see are nice crystal of guanidine isolated in our lab. Next one, please. So mainly there are 2 families of potential interest in resin, which are argentotins, are triterpenes, and guanidine, which are sesquiterpenes. Both of these structure chemically are very active in nature. So just for having this structure, is well known that they can have biological activities. Next one, please. And essential oils, it remains the possibility to isolate of high-priced sesquiterpenes. So from all those compounds I showed you before, could be of potential industrial interest to isolate some of them. Next one, please. So regarding of argentotins, the literature said that they have anti-inflammatory, analgesic, antimicrobial, and antitumoral activities. This studies comes from the last 25 years. Next one. But the challenge in this case, it's that, for example, regarding antitumoral activity, they have nice cytotoxic activity, but it's not too high to consider directly as a main compound on chemotherapy. Okay, so we should consider as an AP, which means an active pharmaceutical ingredient, so an starting material for synthesizing by semisynthesis other pharmaceutical compounds. Next one. This from all these activities, our research team focused in anti-inflammatory and anti-tumoral activity. This is some of our research paper. Next one, please. You can most of our research activity is published in open access. So at the bottom of this slide, you can find the link. You can download free of charge. So as anti-inflammatory, we realized that argentatins promote the production of anti-inflammatory cytokines, and in the opposite promotes avoid the production of pro-inflammatory cytokine. This is very very good news, as argentatin are promising agents in autoimmune or allergic disease. Next one. Regarding anti-tumoral potential activities, as I said, as they are not like it's difficult. We are working in this semisynthesis to enhance the activity just by modifying the structure of these compounds. But in parallel, we are considering a different approach, which is the combination therapy. Now it's very common in the hospital that the patient receives more than one chemotherapeutic compounds at the same time, for two reasons: to enhance efficacy, but also for avoiding drug resistance. For example, in lung cancer, cisplatin is the treatment for choice for lung cancer. Okay, next one. But the problem is, it's well known that it's very common. Next one. It's very common to have resistance to this. So we demonstrate that argentatins can do two things. One, the resistant cells appear. Using argentatin, we can sensitize these tumor cells, so we are able to kill again a much lower doses than the resistant doses needs from this cisplatin, but produce so high secondary effect in the patient that are not useful. And in second, we demonstrate that it's possible to combine. There is some kind of synergism because they are using different I think that maybe Mauricio, too much time? You appear?
You still have time, but when I appear, it means
okay.
We're close to the end of the time.
Okay,
So
2 minutes.
Go on.
So next one. And also in anti-tumoral activities, next one, please. We dedicate time to avoid another key process for tumor, which is cell invasion and angiogenesis. The tumor trying to create more blood vessels to feed better around. So next one, please. The same for guanulins are known like termicide and antifungical. Next one, please. So we try to focus in as it's used as biopesticide with very nice results in very different kind of pests, different arthropods, not only insects. Next one, you can check the information there. And finally, we try to test in cosmetic with nice result for guanulin D. These results also are published in this compound has nice antioxidant activities, but also the capability to regenerate epidermis. Next one. So finally, the conclusion is Guayule is an amazing platform to produce compounds with potential industrial interest. But the challenge is to scale up the industrial process for any of these co-products with the idea to generate return and activate the circle between cultivation and exploitation. When we are able to do that, we can exploit the rest of the co-product. But first of all, it's necessary to obtain return to the farmers, of course, but also to the industrial companies extracting this. Thank you very much for your attention.
Thanks to you. Thank you, Manuel, for this very, very interesting presentation where you explained how precious this crop can be and how it is important to adopt a biorefinery approach and a value chain approach to exploit all the co-products besides the most abundant ones, and to go beyond the rubber only to make it profitable, which is of course the one of the most challenging parts. And we will touch on this subject of how to scale up and how to deploy the value chain at scale exactly from this presentation on, and then on the panel with the industry experts later. So I would like to give Michel Doger the floor. Before I give you the floor, Michel, I invite Manuel to check the question and answer panel if there are any questions addressed to him, and maybe you can type your answers if that's the case. And Michel, the floor is yours.
Okay. 1 second in order to share my screen.
Yes, just put it in full mode.
Yeah, is it okay?
No,
Okay,
not
so
yet.
thank you, Maurizio, for your introduction, and also for
Now it's in full mode.
the organization of the webinar. It's a very nice place to talk about Guayule. In my case, I will focus on the latex production from this Guayule plant, and we will see that it's really a new natural latex that is good for the planet and good for the people. In the case of Guatex, we start our Guayule activity since a long time because all the partners of Guatex, CIRAD organization and also CTTM, were partners of the MIDAS Project 15 years ago. So we have a long history in this area. So we have to be clear, there is two different routes in order to produce polyisoprene from the Guayule. You can use solvent-based extraction process, acetone and hexane, in order to produce polyisoprene alone, dry polyisoprene, that can be called rubber. But it's also possible to use a water-based extraction process in order to produce latex, the liquid form of the polyisoprene. It is a water-based polyisoprene dispersion. With this latex, it will be possible to produce glove, and with the rubber, it will be possible to produce tie. And you can see some picture coming from USA, where they already have a huge quantity of field and also a demo scale extraction unit. So we are all looking for profitability because we know how to produce. It's already published on patent. We know how to separate the different components, but the most difficult thing is to identify the good business model in order to reach profitability. And when you look at the different patents, the different publications, the communication of the company, you can define 4 different routes in order to reach profitability. The first one could be to increase the yield, the in-field yield, especially to develop new variety of Guayule with high polyisoprene content. It's the first strategy. The second strategy to focus on the niche market. And in the whole co-product, the most valuable product is the latex, the polyisoprene latex, and we will see why in the following slide. And we chose in Guatex company to target this niche market. Another possibility is to progress in the value chain. You can produce rubber to produce tie and to sell the tie. And you don't want to sell the rubber. It's only an intermediate raw material for the tie production. And in this case, of course, for Nokian company, for example, the economical equation will be fully different because it will be the price and the value of the tie at the end of the value chain. And of course, we all talk about the co-product because in this plant, we can produce latex and rubber, but in addition to this first 2 raw material, it's possible to produce resin, bagasse, essential oil, and all these co-products will generate additional income, and also all these co-products will give a profitable, good environmental impact, positive impact, because we will have no waste at all. We valorize all the plant. So in our case, we work with farmer and also cooperative. We already have 6 hectares of Guayule field in the south of France, and we buy the biomass to the farmer once it is mature, after 2 years of growing. We put this biomass in our extraction unit. It's a pilot scale extraction unit. We use only water. There is no solvent at all. There is no chemical reaction during this process. and we produce latex. With this latex, we can coagulate this latex in order to produce rubber, of course. In addition to the latex, we will produce also resin and bagasse. And of course, there is several partners in the MIDAS project who focus their interest in the resin and in the bagasse valorization. In the case of latex, if we use no additive at all in the process, it can be considered as a natural extract. So in the REACH regulation, it will be classified as a natural extract. If we use some additive in order to increase the productivity or the quality of the product, it will no longer be a natural extract. It will be a chemical product as a lot of other chemical products. So we have one extraction unit that can produce 1 kilogram per hour. We start in the UPERS project 15 years ago at the lab scale. We patent a process and we extrapolate this process. We scale up this process at the pilot scale. And now it's possible to produce liters of latex per day in order to send some sample to different partners in different applications. There is a very different application for this latex. It can be for the glove, of course, but also for the textile induction. But there is also some specific application in a specialty chemistry area, for example. So what is the difference between Guayule latex and the other lattices? Because we have to compare this new product to the previous one. Of course, there is EVA latex coming from Asia, 100% 100% imported from Asia. But there is some allergenic protein inside this latex, and it can generate allergy to the people who use gloves. In the case of Guayule, there is no protein at all. So there is no problem with allergenic aspect. And we have also to compare to synthetic latex, and especially to the polyisoprene synthetic latex, the Cariflex product. The three different latex, EVA, Guayule, and synthetic, is made of polyisoprene, natural or synthetic. And in the case of synthetic polyisoprene latex, the mechanical properties are very good, comparable to Guayule. And in the glove application, a glove made of Guayule will be softer and stronger. So the behavior of the glove will be more interesting in comparison to EVA latex without any allergenic protein. In addition to this, of course, there is a very sustainable route which generates very low quantity of green gas. Guayule generates less CO2 than EVA and even less than synthetic. In the case of EVA, you will have the cost, environmental cost of importation from Asia. And in the case of polyisoprene synthetic latex, you will have the use of petrochemical component. In addition to this, there is a relation with the cost. In the case of EVA, the cost is quoted in Singapore Stock Exchange. And in this curve, you can see 20 years of a fluctuation, very huge fluctuation of the cost. It can be between 1 to 5 euro per kilogram, dry kilogram. I talk about only the polyisoprene, not about the water, because in the latex there is half water and half of polyisoprene. So it's dry kilogram. And a lot of people decide to use synthetic latex, 10 times higher the price, because they are sure that you will face no allergenic problem and the mechanical property will be as good as with EVA. If you want to have cheaper latex, you can use nitrile latex, but the mechanical properties are very, very poor. So if you want to have the same properties, the same mechanical property, you have to use synthetic polyisoprene, and it will cost 10 times higher. And people are ready to pay such high price because they don't want to face any allergenic problem. There is one standard, an American standard dedicated to natural latex. it deals about EVA latex, but also Guayule latex. And in the case of Guayule latex, it corresponds to category 4. And in this table, you can see that there is no protein at all in the Guayule latex. And in addition to this, you can also see that there is some data dealing with mechanical stability, because when you work with a latex, it's an unstable situation. It's a colloidal structure that can be unstable, and you have to evaluate the colloidal stability. In the case of Guayule latex, we have two different routes in order to evaluate colloidal stability. You have the mechanical stability. You share the latex and you evaluate how long it takes to coagulate the latex. And in the case of Guayule latex, you have to be higher than 19 seconds in this kind of evaluation. And you have also to evaluate the chemical stability in front of calcium. And in the case of the glove production, in fact, you put some calcium on the surface of the mold before putting the mold in the latex. And it is not a drying process, it's a surfaced coagulation. So you want the coagulation to occur as fast as possible, and that's why the chemical stability in the glove application should be lower than 2 minutes. Each point on this diagram corresponds to a different kind of Guayule latex. So you can see that it's possible to develop a huge range of Guayule latex with different chemical and mechanical stability by modifying the extraction process, by modifying the additive during the process, and by also modifying the additive after the extraction. So we are presently developing a range of latex and also a range of rubber after latex coagulation. That's why we are focusing the glove market, because it will generate profit, because it will give more comfortable and safer and sustainable glove using a local production of natural latex coming from Guayule. So you understand that there is a lot of application using latex or using rubber, and all this application will have a different market size and will have different market value. In the MIDAS project, we are targeting several applications. So with solvent-based extraction process, it's possible to produce rubber for the tire application. And with water-based extraction process, it's possible to produce latex for the glove application. And in fact, these two routes is really interesting. And maybe in the following years, we will develop plant with the two way of extracting latex and rubber, because there is a nice synergy between these two processes. It will generate different quality of co-product, and all these co-product will be valorized. In the case of Guatex company, we are at the pilot scale. We already have a 1 kilogram per hour production capacity, and we are modifying presently the process in order to increase this capacity to 10 kilograms per hour. We validate the quality of the product with several partners in several applications, latex and rubber. And now we need to increase our production capacity. And in order to do this, we are working on the first fundraising, Series A fundraising, 3 million equity, in order to reach demo scale with a bigger capacity of production in order to make some industrial evaluation with our partners. Once done, it will be possible to launch another fundraise, Series B fundraise with 10 million equity in order to reach industrial scale with a huge surface of Guayule in order to produce the biomass and enough capacity of production for the European market. And we will see in the other country if we want to develop additional extraction unit. So as a conclusion, I can say that it's a very nice, profitable market. if we have an evaluation of the latex market, not the rubber market, of the latex market, it's 12 billion euro at the global scale, worldwide scale, with a huge increase around 5%. If you evaluate the rubber market, it will be 10 times bigger. It's really bigger for the rubber. If you concentrate on the soft latex application and the high technical application, high value application, you will find 3 billion euro at the global scale. It's enough for a company like Guatex, of course. In addition to this, we identify that it's good for the sovereignty because rubber and latex coming from EVA has been classified as a critical raw material at the European scale. So it's a very important raw material. Without latex, no glove. Without rubber, no tie. It will generate employment, farmer and industrial employment, and it will allow the glove producer to produce more comfortable glove. In addition to this, we already talked about life cycle analysis. It is good in order to valorize wasteland, to fight with the climate warming, to help farmer to develop a new product, new production. And in addition to this, we use an eco-extraction in a biorefinery strategy. And that's why the Solar Impulse Foundation labelized consider that Guayule latex is really an efficient solution because it is good for the planet, good for the people, and good for the profits. Thank you for your attention.
Thank you, Michel. It was very, very interesting presentation. We are a bit behind schedule, so in the interest of time, I will now introduce our industry experts for the panel, and I will keep my questions for you for the panel. So I would like now to invite the first one of our industry experts, because now we would like to extend this discussion to industry experts to understand how to scale up and what are the challenges to scale up and deploy these value chains at scale. And the first one is Juha Piironen from Nokian Tires. Juha, I think you could probably give a first introduction about the activities of Nokian Tires, and then my question to you is what I just said. What do we need? Where are the bottlenecks? We know there are many, of course, but from your point of view, what do we need to scale up these value chains? The floor is yours.
Thank you very much, Maurizio. I will keep this short to catch up the schedule.
Don't worry, we have time. We have time.
And should I share, or would you share the?
Let me find that. Maybe I can share. Yes.
Okay. Thank you. This is a nice photo of our field from Spain. The Toledo area, it's the village is Santa Cruz de la Zarza, actually near Madrid. And you can see our field of Guayule in this photo. The next, please. What we are doing in Nokian Tires is, of course, to focus in sustainability, and because we are a Scandinavian tire producer, there is a history of strong will for sustainable production and also for innovative tires for passenger cars, trucks, and heavy machinery. Next, please. And here are some details of those long-term competitiveness on our core strengths. You can see we are producing tires for all conditions. Of course, the winter tires is one of our specialties, and one which I will again say that we are leader in sustainability, and that is one of our strengths also. The next, please. Here are the key sustainability goals in our company. The one is reducing CO2 emissions in line with our ambitious science-based targets and bringing new environmental and safety innovations to our products. One of them could be in the future also the Guayule natural rubber. And decreasing, besides those, decreasing accident frequency and improving inclusion and equality, which are the values in Scandinavia, very strongly marketed also for the different industry levels. And all sustainability high-risk suppliers have been audited also. The next, please. The key climate target reads 7 years in advance. Actually, one of our science-based targets was to cut the tire factories' CO2 emissions by 52% per product ton between the 15 and 30. And we achieved that target already in 2023. Maybe here is also mentioned the sustainable raw materials. We explore the new raw materials and targeting to increase the share of recycled and renewable materials, which we called R&R materials, to 50% by 2030. And the net zero commitment is also included. We are committed to set emission reduction targets in line with the net zero targets of the Science-Based Targets Initiative. And one point is to be mentioned is that we are included in the Dow Jones Sustainability Europe Index, and we are at the moment among the most sustainable listed companies in Europe. The next, please. And what is inside the tire? This is in focus, a passenger car winter tire. In this photo, it's a Nordic winter tire. The main parts of the passenger car tire, the synthetic polymers, natural rubber, fillers, chemicals, and reinforcement materials. And you can see in this graph the share of materials used in percentages. The next, please. What is the plan or the possibilities of usage of Guayule actual? In this webinar, there has been a lot of talk about rubber resin bagasse already. They are also included in this slide. But if you can see here, for the rubber, there are different kind of products coming out of the Guayule natural rubber: diving and surf suits, medical devices, tires, gloves, other rubber goods like sealants, hoses, whatever. There is plenty of products to be included in the usage of the Guayule natural rubber. And of course, some examples for usage of resins and bagasse are included in this slide. And what about then how to build the Guayule value chain? The building the complete value chain involves developing an integrated system from cultivation to end product manufacturing. And step-by-step breakdown could be presented in this slide in general, not going to the details, but first from the left, the cultivation and agronomy, the site selection, seed supply, breeding, and farming practices could be included in the cultivation and agronomy. They are maybe the most important steps, and of course the harvesting after that. And there has been in MIDAS project also a lot of activities including this part. What is not so much included in MIDAS is the next steps like the processing and extraction and the R&D and quality assurance for to be able to make really the rubber products. And this is much more tricky than people normally think about, because the processing and extraction has to be think about again how to make it from the raw material, the value chain to the factories in different countries, and also how to make the rubber products usable for the customers. The byproduct utilization is maybe one of the keys. In the right part of the slide, you can see again the rubber resin bagasse, and that is the key for the manufacturer and product integration to get really the step-by-step process ongoing. And on the bottom of the slide, you can see the sustainability and circular economy, partnerships and ecosystem development, and in the later stage, the commercialization and market development, which are essential for the real value chain in the end. Maybe the next slide, please. Here are again the 3 steps, the agricultural part, and here are those critical points which are the most important in each step. Maybe the high yield per hectare, minimum cost, minimum total biomass usage. And when you come to the industrialization, the maximum throughput, the optimized quality, cost-effective and scalable processing technologies. And in the right part of the slide, there is the effective usage of all parts of the crops, which has been said many times in this webinar, the rubber resin bagasse, and the lowest environmental impact and the most economical result. They all must be included to real Guayule value chain to work. Is there another slide?
I don't think so.
Maybe this was it. Thank you very much for your attention.
Thank you. Thank you, Juha. I also have a question for you. I hope we have enough time before I would still like to give the floor to our next and second industry expert, Adam McCarthy from Tires Europe. Adam, please share your views, and I hope we have the time for a common discussion later.
Thank you, and thank you for the invitation. As opposed to my colleagues, I'm not going to sort of present slides today. I think there's been some fascinating presentations, but I did really want to perhaps use my intervention to perhaps even start that debate, that discussion that we're going to have. But please, if you allow me, I'll just say a few words about Tyres Europe, who we are and what has changed over the last couple of weeks with us. So Tyres Europe is the European Tyre Manufacturers Association. Up until the 24th of October this year, we were the European Tyre and Rubber Manufacturers Association. However, we have, with the members, including colleagues from Nokian, it's really been decided to establish and create an association at the European level, which is focused on tyre issues. It's really felt that having that focus will really allow us to really, I think, focus on those issues that really matter for the tyre industry. And I think the discussion today is a wonderful example of the need to perhaps be a little bit more expansive in our thinking, to perhaps be a little bit more ambitious in the work we're doing as an association. In terms of who we are today, we are 13 tyre companies, all of whom are producing tyres within the European Union. The members are represent approximately 70% of global tyre production, and a similar number in the European tyre market, depending on different parts of the market. The industry today, the manufacturing industry today, is contributing to approximately 48 billion euros a year towards the EU's GDP, and is supporting in excess of 500,000 jobs, both directly and indirectly. And I think is probably the largest user of natural rubber in Europe today. To give a little bit of context, I think, to our discussion today, it's probably worth remembering that over the last 5 years or so, the industry, the tyre as a product, the tyre industry has faced what we would term as a more or less a tsunami of legislation and regulation. We're having many different pieces of regulation, some of which are very relevant and very important in terms of impacting and affecting not only the supply chain. If we think about the deforestation regulation, which although potentially delayed again, does have rules for the first time around the traceability of natural rubber for the industry, particularly focusing on rubber coming in from what I would term the more traditional producing crops and regions such as Southeast Asia, West Africa. This is a huge investment that has been required by the industry. This has been a huge effort to get ready for that regulation. At the same time, we are seeing product regulation, which are for the first time requiring us, or will require us, to use increasing amounts of biomaterial in the tyre, and also alternative, perhaps more sustainable sources. So in the coming years, we will be dealing with the so-called eco-design for sustainable products regulation, which will really actually set out rules around what we can and should be using in the tyre. And I think all of this is very relevant for natural rubber. And as if we actually think about rubber from a European perspective today, and I think it's been mentioned a couple of times, we are 100% import dependent today on the materials we are using in tyres. Depending on the tyre, and Juha knows this far better than I, but around 20 to 25% of a tyre is natural rubber. So natural rubber is a critical material for what we believe is a strategic product. Without tyres, put simply, your economy very quickly stops, society very quickly stops. And if we start to think about the current geopolitical instability, having more than one source, one geographical source, one crop source of the rubber is going to be increasingly important for Europe's strategic autonomy. This is partly why one of the things we as an association have been doing is calling for the European Commission to develop a rubber strategy. I think Michel alluded to earlier on that natural rubber was considered as a critical raw material. Today, because of mathematics, it is not considered a critical raw material. But I think we are calling for it to be considered again as a critical raw material for, I think, the reasons we are all aware of. We are calling on the Commission to establish a rubber statistical observatory so that we can actually start to see the amount of material being imported, any gaps that we might start to see in the market. So that the market can actually start to predict and start to see what happens. And I think having that focus and being considered as critical then does open new possibilities to find perhaps more domestic production of rubber. And as part of any strategy, we do need to look at diversification. We do need to look at alternatives to what we have today. So this rubber strategy should really put that resource autonomy and also the bioeconomy at front and center of what we do. And I think we've heard today some of the things that we would probably start to need to see that happen, so that we are increasing the focus on producing domestic sources of rubber, whether that be through support through agricultural support mechanisms, whether that be increased targets through pieces of legislation. I think these are all things that we are increasingly pushing for as we start to see, from our perspective, a tire as a strategic and critical product. And that also needs to be thought through in its supply chains and where we're actually sourcing some of those raw materials from. So with that, I'll stop. I hope that didn't go on too much, but I hope that sort of gives a sense of where we're really focusing our efforts and attention.
Thank you, Adam, for this overview and for sharing your views. And we understand that there's really a need to focus on the co-products and that the policy is complex, but it still enables the condition. It creates the conditions for it makes more than the policy, the geopolitical conditions make for Europe even more important to deploy this value chain for security reason and to increase also our competitiveness through innovation. Thank you. So I have a question to Michel now. We still have 5-10 minutes more or less. Michel, we shared our views many times, and you also many times raised the issue of there is a bottleneck in the agricultural part of the value chain. And can you elaborate a bit very quickly on that? And then I also have a question to you.
Yeah, thank you. Thank you, Adam, for the focus on the critical raw material, because for sure it has been classified as a critical raw material some years ago. Now it's out of the list, but we have to work in order to reintroduce natural rubber in this list, because in the tire application, it's not possible to use recycling rubber because it's a too high level of application for using a recycling rubber. So we have to work on this. The second issue is related to the common agronomical policy. Presently, when a farmer tries to grow Guayule, it's not possible to receive some subsidy from Brussels, because you have to declare what you are growing on your field, and there is a positive list. And on this positive list, it's impossible to find a route in order to say that, okay, I'm using Guayule, but I want to receive the subsidies from Europe. So presently, you lose your subsidies when you grown Guayule on your field. So we have also to work on this second issue, how it will be possible in the following years to add Guayule in the positive list of the agronomical policy. And in fact, there is a latest issue. It's also a common issue. Say, the guayule is a problem for the whole latex and rubber user, not only one, the whole user. So we have to identify how it will be possible to invest in this new route. Maybe it will be by creating a new joint venture between several dye producers. Maybe it will be to create an association of all the people who will use the different co-products in order to finance in equity all this new route and all this new business.
Thank you, Michel. This is indeed a very, very important bottleneck at the agricultural level, and we are tackling this with MIDAS. I think with this webinar helped to clarify a lot why this value chain can be strategic for Europe, and we have elements through your presentations from all the speakers today to work on a sort of policy recommendation or a policy paper to convey, to address to the policymakers to understand this regulatory aspect on the positive list that you mentioned, for related not to the eco schemes, but if I understood correctly, because it's still a bit complex also for me, to the basic subsidies for the CAP. And this is really important aspect to start to convince the farmers. And this leads me to my question to you first, but also to the other panelists. What is currently your level of engagement, the feedback you receive from farmers? Where is the discussion? At what level is the discussion at this moment to scale up the plantations? Also, because I'd like to include here an element that we got from last week's regional advisory group meeting of MIDAS that we held in Italy, led and moderated by Andrea Monti, which I say hi, and I saw here in the attendees. One of the outcomes of this meeting from the farmers was that there's really a need for strong agro-industrial players that take the lead to build these value chains. But once these are established with strong industrial players that give confidence to the farmers to invest in these new crops, things start to get moving. And we had examples of very positive experiences, for example, on the oil crops. Oil crops are an annual crop. In this case, these are perennials, and we know that it's difficult to convince farmers to invest their time and their land on perennials that stay on their land for 10 or 20 years. Where is the discussion now? At what level? And have you entered into any business model discussions?
Thank you, Maurizio. I would really want to emphasize the point that Michel was pointing out earlier, and the farmers are really struggling with their income, and with this kind of products you really need to have the whole co-products also included. So the resins, essential oils, bagasse usage have to be developed before you can really expand the cultivation of the guayule for natural rubber production. But of course, there are some, would I say, possibilities. For example, the new EUDR will make a difference that it's not so easy to expand the hevea production anymore by just cutting the rainforest. That is the idea of the EUDR in the future. So maybe that helps also something for the European farmers.
Thank you, Juha. We're now close to the end of today's webinar. I don't know if any of the speakers or the panelists have any other final remarks. If not, I thank all the speakers for your time and for this very, very interesting set of presentations and the discussion. I think it will be the start of some additional work for us in the project. We still have 1 more year in this project, and we really need to tackle these aspects. And probably this will be not the last time that we approach the Guayule value chain with these dissemination events. There will be other webinars on other aspects of MIDAS in the coming weeks and months until the end of the next year, where we have planned a series of in-person events, and you will all be informed. I thank also all the participants. I saw that there was a lot of discussion ongoing in both in the chat and in the question and answer panel from stakeholders and from experts in the field. We are still more than 50 participants at this time of the day, so it's really a success for us. All the slides will be, and the recording will be shared afterwards, and please follow us on our page to stay informed about our upcoming activities. Thanks again to you, and enjoy the rest of your day. Bye-bye.